Hello there, it's Jay here from Jay's Vintage Junk, and today I'm actually right in the middle of working on that 286 motherboard at the moment, and I'm pulling my hair out a bit, so I thought I'd stop and have a break. And this arrived in the post this morning, so I thought why not do a quick unboxing video and relieve the stress of working on that 286 motherboard, because it's I'm having fun with that at the moment. Basically what we've got here is my old component analyzer. I've had this for years and years and years. Bought it dirt cheap off eBay, just a little bare board like that, and I ended up building it into this case and adding, you know, proper flying leads and a proper button. I even built a little continuity tester into it, and it's been great this for years. You know, really quickly you know, identify semiconductors, and you know, you can measure resistance, measure capacitance and things like that on it. Problem with it is, like I said, I've had this years, it's fallen off the bench a few times, and the display now is starting to get a little bit iffy on it, where I keep having to open it up and literally push all the bits of the zebra strip back together on the LCD, or else I could start losing big chunks of it. So like I said, I think it's pretty much had, you know, got to the end of its life now, unless I can find a new replacement LCD for it. So anyway, I went perusing on eBay, as you do, and for I think it was about £7 I picked this up. Now I believe this is the same one as our old friend Shango either still uses or at least used to use. And if it is, it's a slight upgrade from the one that I've got there. Let's have a quick, yeah, there's nothing that's going to give me away there. Lovely, get rid of that. I said if it is the same one as I've seen him using it, I think it's a very slight upgrade on my old one. Nicely sealed in a anti-static bag. Let's unseal it. There we go. Yeah, I like that. They put it in an anti-static bag, but actually wrap the whole thing itself in bubble wrap, which kind of defeats the object of the yeah, never mind. Right, what have we got in here? Okay, there we go. Yeah, it does look very much like the one that Shango indeed has, with the little repurposed ZIF socket there for you to put the connectors in. I might be able to modify this case, I don't know, or at least that hole's too big there, isn't it? I might be able to do something and still mount it in there, or at least mount it into something else. I do like something, you know, more than just a bare board like that, hence the reason I went to the trouble of building that one into that case. I might see what I can do. I'll have a think about that, see how I can perhaps mount this thing up. Let me get you zoomed in a bit so you can perhaps see it a little better. Ooh, there we go, that's better, isn't it? Yeah, I've got you nicely in shot there. I'll give you a quick twist around so you can see it. Right, let's get this bit of tape off. Hopefully that's not holding it all together. Oh, it's just, is that, I take it that, that's like an anti, that's a protective, we can pull that off. Yeah, there we go. Yeah, that's quite nice actually. Right, let's give it a try. I've got a brand new battery here. Let's get that connected up. Alright, there we go. Let's see what happens if we just press the button. Oh, I like that, it's nice and backlit. My old one isn't backlit. Right, no known, unknown or damaged part. Alright, so no unknown or damaged part. Let's find something randomly lying around we can shove in there and see what it makes of it. Let me see what if I've got anything just randomly lying around on the bench. I should have paid some more attention before. Ooh, what have we got over there? Have we got anything there? In fact, just bear with us a second, folks. I'll just grab a few things to test, and then we can actually see what this thing's going to do. So, back. Right, okay, we're back. I've grabbed a few components. I think we've got a 10k resistor there. I think we've got 0.1 UF capacitor there. We've got a 100 UF electrolytic capacitor there. We've got a small signal diode. We've got I think that's a PNP transistor, and we've got an NPN transistor. And now I'm not sure whether it can measure these or not, but I've got a little coil there, so that'll measure as an inductor. I don't know how we're going to connect that up to this yet. We might have to just wrap some wires around it temporarily and just try and get that in. It might even, there's a possibility we can get them pins actually to just let's see which way around we want it. Yeah, we might be able to just get the pins to, yeah, possibly. That might work. Right, let's start with something simple. This I know is a 10k resistor because I've just got it out of my 10k resistor pot. In fact, I've just noticed them legs are a little bit on the dirty side, so just bear with me 1 second. I'll just give them legs a quick clean, because obviously we're measuring resistance. If we've got dirty legs, that is going to influence what the resistor, what the meter measures. So just give them a little bit of a clean to make them a bit shinier, as you can see. And we'll go between 1 and 2. I think that should work. Pull the little lever down to hold it in place, and let's press the button. Testing. There, yeah, between 1 and 2 we've got a 10.16k resistor. So remember that, because we're going to have a play at something with something else after. So we've got 10.16k on that resistor there. In fact, just bear with me. Let's grab a piece of paper and a pen, and I'll write that down. You'll see why in a minute. So we've got 10.16k for the 10k resistor. Right, let's try. This should be 0.1 UF. So we've got 1 and in fact, let me do this. Oh, actually, no, those are quite shiny. We should get a good contact on them. That's 1 and 3. Sorry, 1 and, yeah, I think that's 1 and 3. I've got them in there. Right, so again, let's press. So that's, look, that's saying it is 84.52 nanofarad. So let's write that down. That sounds a little bit low to me. Like I said, we'll find out how accurate this is very shortly. Right, okay. Now, what else shall we try? Let's try the 100 UF electrolytic. That is a, I think it's a fairly generic, no brand one. So, and yeah, the legs are a little bit manky on that. Let me just quickly clean these legs. That's better. Yeah, those are clean enough to get a good contact. I'll have to bend them a little bit funny to get it in the tester. That's why on my old tester I actually connected them binding on the banana plugs with little clip leads, because I was sick to death of messing about trying to get certain components in, because it didn't even have a ZIF socket like that. It just had little things to push like pins in. Right, let's try this. Right, oh, that's really cool. Right, so it's saying it's 100.9 UF and it's giving us our ESR as well. So this has actually got ESR capability. ESR equals 0.41 ohms, so it's 100.9 and our ESR is 0.41 ohm. Right. Let's try its semiconductor capability. Now this is more just to see whether it can recognise this NPN or PNP. We're not really going to test this against anything else. Just want to make sure it can happily work. So I think this is an NPN one if I'm right. Yep, there we go, NPN. It tells us base is on 2, collectors 3, emitters 1. It gives us the HFE. Yeah, it's fine. That's really cool. Right, let's just make sure it can do this NPN one. Sorry, this PNP one. At least I think this is a PNP one. There we go. Let that switch off. Let's put this other transistor in. And again, let's press the button. Oh, that's another NPN transistor. Oh. Oh well, never mind. At least it's showing us it's working. Some of my boxes got a bit knocked about a while back, and some of the transistor drawers did get mixed up, so I will have to go back through. Ooh, go back through them. And I've just dropped that small signal diode somewhere on the floor. Let me see if I can find it. Come on, diode, where did you go? Oh bugger. Well, that's never to be seen again. I tell you what, folks, I will go and I will actually see if I can hunt out a PNP transistor, and I will get another diode. So back in a sec. Right, okay, we're back, and I've dug out another small signal diode there, and I've also dug out what I know is a PNP transistor. We've got an LCR-T4 there, brand new old stock. If any of you old timers remember CPC packets from back in the day like that. It's a brand new old stock. Right, let's start with that anyway, and let's see if it can recognise this PNP transistor. I think it'll go in. In that hole there. I don't want to cut these legs, obviously, or bend these legs, because this is a brand new old stock one, and these are getting very hard to get now and getting very expensive. Right, let's see. Is it going to test it? Oh, diode. Oh, that's not good. Hopefully we've just got a bad connection there. Let's try, just make sure we've actually got a connection, because I think it was only measuring between two of the junctions there. Right, let's try that again. There we go, PNP transistor, lovely. HFE 205, 103 millivolts. Right, okay. Not that we're going to need that information. I'll pop that away, and that can go back in my stocks. Not got very many of them left. Right, let's try this little small signal diode. Well, I've gone between 1 and 1 there. Let me just move that leg across a little bit. Right, there we go. Let's try that again. Yeah, there we go. It recognises it as a diode, 700 millivolts drop on it, I presumes. Lovely. Now, the thing I really wanted to find out is, can this measure inductors? because if it can, it's definitely one step up from my old one, because that one couldn't measure inductance. So let's find two of the windings on here which will be in inductance, so we can use them 2 pins there. That's one full winding, I think. Let me see if I can get this to... It's whether I can get this into the actual tester to make contact, that's the problem. We'll see. No. What I might have to do is I'll wrap a couple of bits of wire around them pins, and I can perhaps try... I've got a bit of hookup wire here. So I've got another piece of this, and we'll see if this will work. Alright. Right, that'll do. If I wrap that around there. We'll probably be better to solder them on, but I'd rather not. These are actually the inductors for Spectrum 48K motherboards. I know a lot of people convert them now, but I do like to keep things original. I do still have a few brand new old stock ones of these about. Right, there we go. I've got a wire around that. I wonder if I can get one pin to hold in there like that. Yeah. And then I bend that round and I shove that in another hole. Like that. Sometimes you have to be creative when you want to connect something up. Okay, that in there. Ooh, thought I nearly had it then, damn. There we are. Oh, no. I'll tell you what, folks, I'll see what I can do about getting this connected up to there, and I'll be back in a sec. Right, okay, there we go. Just got a couple of wires, managed to wrap them around the terminals on that there and connect it up. So let's have a look, let's see what this shows up as. There we go, yeah, that's working great. So it's showing it as the inductor, 0.3 ohms, so we can write that down. So we've got 0.3 ohms, and it is 0.01 microhenries, so we've got 0.01 mH. Right, lovely. I'm really quite surprised with that. That's quite a nice little piece of kit. Like I said, this was under £8. I'm probably not going to leave it exactly as it is here. I'm probably going to case it up in some way. Certainly probably do something better than that, because I mean, as these are, I can't see them lasting very long, you know, bashing around in a drawer, especially considering, you know, your little microcontroller is right on the back there. You've got all this surface mount stuff, you know, literally just on the back there. No, I think I am going to probably, like I said, case this up in some way. Possibly there's even a pad there. I think it's meant for doing, you know, pushing certain surface mount components onto for testing. But I could probably just pinch off those pads there and do the same as I've done on the other ones with some banana plugs, and be able to actually plug leads in for more realistic testing. I might still be able to use that though, and keep that on here. But yeah, so far I'm reasonably pleased with that. But what I wanted to check, and seeing I've still got this with me, and I really do need to get this back to my mate Andy, but I've got my mate Andy's Peak Instruments ESR and LCR meters in here. Now this is proper kit. This isn't cheap Chinese junk. These are made in England. Actually made quite close to where I live. These are made up in Derbyshire, and it's only probably about 25 miles from where I live. And like I said, these are great. I actually own one of these myself. I have the Atlas LCR meter there. Unfortunately, I've owned mine since I think I bought mine about 2006, 2007, around about that kind of time. And it's been used and abused and hammered. It's had lots and lots of abuse, and I cannot for the life of me find out where I've put it. I know mine needs a repair. These do suffer from a few little issues, either battery leakage because they use got something here actually I can show you. They use these kind of 12-volt cells inside, and occasionally, it's not very often, but occasionally these can leak. And especially if you buy dirt cheap ones, don't buy them from pound stores or place like that. These are actually reasonable ones, but in fact these are actually slightly expired and they still work absolutely fine. But yeah, mine has suffered a few issues. It got put in a drawer and I cannot for the life of me find it. But I thought as well, I've still got these before I give them back to Andy. What we would do is we'll compare a few of the things between El Cheapo there and some proper kit. So let's start with that resistor. Now obviously we can't use the ASR meter for that. That is just for testing that electrolytic capacitor and seeing how that relates to what we've got on the paper there. But the LCR meter, this can measure inductors, capacitance, but it can't measure ESR, just capacitance of resistance. So like I said, we'll start and we'll see what it gives us for this 10k resistor. Remember, the cheap Chinese one gives us 10.16k. So we'll connect that up like that. Press on. .96k. So we'll write that down. 9.96k. We will also measure, that was the it should be a 0.1 capacitor. I think we got 84.52 nanofarads using the cheap El Cheapo Chinese one. Let's see what this is going to tell us. Can you see that? Right, and that is showing us quite a different type. That's 103.1 nanofarads. So let's write that down. 103.1. NF. That's quite a difference between what this is showing, and to be honest, this is what I would trust rather than the El Cheapo or Chinese one. Right, next, what did we say we was going to do? Well, I'm not going to bother measuring the electrolytic with that. In fact, let's go right on and measure that inductor with this, and then we can put that away and we can have a go with that electrolytic capacitor on the ESR meter. I'll take these wires I bodged on off. I did just twist them round so it's easy enough. Make sure we pick the same winding, because you've obviously got two windings on these. Let's see what this comes up with the inductance. I'm hoping this is going to be something similar to what the cheapo one's telling us. Hopefully you can see that. Right, 16.5 UH. So that's 16.5 UH. That's completely different to what, let's see if it'll give us the 0.5 ohms. So it's not even same there. I would much more trust this than El Cheapo Chineso. Right, let's see what it's like for the capacitor on an actual ESR tester, because El Cheapo give us 100.9 UF and it gives us a 0.41 ohms on the ESR. Let's see what a proper Atlas will give us. Make sure that capacitor is charged and well discharged, just in case. Let's switch that on. Right, 99.72 UF. That's actually fairly close. It's telling us we've got an ESR of 0.28. That gives us 0.41. It's actually closer than I was expecting. So we've got 99.7 and we've got 0.28R. Right, interesting. I'll turn that off. And these can go back in the case, and I will get them back to Andy ASAP. But yeah, so from what I can see, it's fairly reasonable for resistance. It's not brilliant, but it's fairly reasonable to measure resistance. It's a pretty abysmal measuring small capacitances. It's fairly abysmal measuring inductors, even though it says it can do. It seems fine for measuring transistors, and it seems fine for recognizing other semiconductors and things like that. But yeah, I wouldn't trust it for measuring small capacitances and things like that. I wouldn't trust it for measuring inductors, which is a bit of a shame, because it would have been nice to be able to use it for that. I'm going to have to keep hunting and see if I can find my actual Atlas LCR, because those are far superior instruments. But I said it was £8. I can quickly use it to measure transistors. I can quickly use it, just to quickly test a resistor. In fact, I can quickly use it just for testing electrolytic capacitors before I use them. So for what it cost and what have you, yeah, so I won't be using it for measuring inductors and things like that. I won't be using it for measuring small capacitances like that. But for everything else, it actually seems fine. Well, for the money, yeah, I'm quite pleased with that. Anyway, I'm going to leave it there for now, because it wasn't meant to be a long video or anything. It was just meant to be a bit of a respite for me for pulling my hair out with that 286 motherboard, which hopefully there should be a video coming up for soon. So I've made a tiny bit of progress on it. I kind of know sort of where to at least look for the fault on it now. So we are slowly getting there. Anyway, I will say hope you enjoyed that. Thanks for watching and goodbye.